Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Mudasir Abbas. My presentation topic is X-ray diffraction technique. In this lecture, we will discuss the remaining portion of scanning electron microscopy. This chapter comes under the main course of X-ray diffraction technique with the course code of CAM 5134. Dear class, this technique is used for amorphous materials. Amorphous materials do not consist of atoms arranged in ordered lattices but in random solids. Amorphous materials are completely disordered. The electron diffraction pattern will consist of fuzzy ring of light on the fluorescent screen. The diameter of the rings of light are related to average nearest neighbor distance in the materials. Diffraction pattern give crystallographic information about a material from site-specific small volume, unlike X or D, which is a bulk analysis technique. We can determine if a material is amorphous, crystalline, or polycrystalline quickly and effectively. Lattice parameter information, unit cell details, and any periodicity present in the sample arising from structural transformations or ordering process can be seen. Superlattice structure gives information about the long-range makeup of a materials. Amorphous materials, crystalline materials, and polycrystalline materials. These are the three figures about materials. A amorphous material, B crystalline material, and C polycrystalline materials. Types of electron diffraction patterns: ring pattern, spot pattern. Ring pattern from polycrystalline specimen. Major uses are identification of the phases, analysis of texture, determination of the camera constant L lambda. Major uses of spot pattern: the foil orientation can be determined, identification of the phases, the orientation and relationship between structure can be determined. Advantage of the electron diffraction: diffracted beam has high intensity, can handle nano-size crystal, material needed in small amount, cell symmetry and cell parameters can be easily extracted from electron diffraction patterns. In TEM and SEM, particles are individually examined and particle shape can be measured. Disadvantage of electron diffraction: electron diffraction is more expensive and more time consuming. It must be done in high vacuum and only transmission electron microscope are capable of doing this sort of microscopy. TEMS are extremely expensive. Samples that are prepared for electron diffraction must be made extremely thin. Sample for materials such as emulsions or difficult to prepare, low throughput, not for routine use. Differences between X-rays, electron and neutron diffractions. X-ray diffraction, electron diffraction, neutron diffractions. Wavelength needed for crystalline diffraction of the order lambda is equal to 1 angstrom, of which is same size as an atom. In electron diffraction, wavelength needed for crystal diffraction of the order of lambda 1 angstrom. In neutron diffraction, wavelength needed for crystal diffraction of the order of lambda 2 angstrom. And energy for X-ray have energy E is equal to 10 की power 4 electron volt. Electrons have the energy nearly equal to 40 electron volt, and neutron have the energy nearly equal to 0.08 electron volt. X-ray is the cheapest, the most convenient and widely used method. Electron beam can easily produced by the cathode tube, easily available. Neutron source in the world are limited, so neutron diffraction is a very special tool and very expensive. X-ray interact with the special distribution of the valence electron. In electron diffraction technique, electrons are charged particles and interact with matter through the Coulombic force. This means that the incident electrons feel the influence of both the positive charged atomic nuclei. Neutron source is the word and limited, so neutron diffraction is a very special tool and very expensive. Neutrons are scattered by the atomic nuclei through the strong nuclear force. In addition, the magnetic moment of neutron is non-zero, and they are therefore also scattered by magnetic fields. Applications of electron diffraction include crystal orientation, phase identifications, microstructure determination, texture determination, strain determination, structure determination. In biology, electron diffraction provides valuable information for evaluating specimens. Damage that can occur either during specimen preparation or while in the electron beam. Dark field electron microscopy can be used both to enhance the image contrast and to provide highly restricted and highly specific information about the object. In pharmaceutical industry, electron diffraction has been recently used in the pharmaceutical industry to study the polymorphism in crystalline during substances. In mineralogy, electron diffraction combined with electron microscopy is used to study mineralogical problems. In structure characterization, electron diffraction combined with bright and dark field observations of the sample provide an efficient way to determine crystal structure related to specific morphology. LED is one of the most informative technique for determining the arrangement of atoms close to the surface. LED is used in chemical analysis. It is LED patterns are used to assess the defect density. Limitations. Electron diffractions has following limitations. Samples to be studied must be electron transparent, meaning the sample thickness must be of the order of 100 nanometer or less. Not applicable to samples which are vulnerable to radiation damage caused by the incident electrons. Not applicable for the study of the magnetic materials because of the fact that electrons are deflected in magnetic field by the Lorentz force. Thank you ji. Allah Hafiz.